Right. In the previous tutorial, we talked about the solar system and various components that makes up the system. In today's tutorial, we are going to talk about a special component of the system, which is the solar resource. The solar resource is basically the energy that we are getting from the sun. This energy comes through in the form of radiation. And the sun has got a wide range of wavelength that that moves to the earth, from ultraviolet radiation, visible, and long wave radiation. The energy that we are going to be capturing is mainly in the visible spectrum. We know that the sun, or rather the earth, revolves around the sun, and the earth is moving, or is rotating on its axis. We know that the earth rotates on its axis, and as it does that, it is also moving in an elliptical orbit around the sun. That movement of the earth brings about variation and intermittence of the energy that we want to collect from the sun. So understanding of the behavior or the relationship between the sun and the earth is of paramount importance. We will summarize it so that it's understandable and it is making sense to a lot of people. The solar resource is affected by or varies in accordance to the time of the day. What time is it? Is it in the morning? Is it in the afternoon? Is it in the evening? Is it at night? So it varies throughout the year depending on what day number of the year is it. It also varies depending on the atmospheric conditions of that day, whether it's cloudy, whether it's humid, is it raining, right? And when we are talking about this resource, we have to understand that it is maximum collected when the radiation is hitting the collector at normal or at 90 degrees to the collector. Hence, it varies in accordance with the tilt from the horizontal plane of the collector. In other words, the collector is supposed to be tilted such that the radiation is hitting its surface at normal. In the southern hemisphere, all the collectors are supposed to be facing north, and in the northern hemisphere, all the collectors are supposed to be facing south. This is called the azimuth of the collector. Why is it important to understand these variations or these characteristics of the solar resource? This is an input to the design philosophy. Whether you're going to design a system that wants to maximize the collection throughout the day, in that case, you would need to design a tracking system that does track the sun as it rises from the east and it traverses the sky and sets to the west. If it is not a tracking system, suppose it's just for a domestic use, you wouldn't want to involve a lot of components. Ultimately, the cost would be very high vis-a-vis the benefit. So for domestic use, you would want a fixed system, but knowledge of where the collector is supposed to face and at what tilt angle would then ultimately gives us the energy that we want. Because at least we will know where to face the solar panel and at what tilt angle should we face it. There are components of this radiation that I wish to talk about. As the radiation comes through from the sun to the surface, it passes through the atmosphere. In the atmosphere, there are particles, dust particles, there is clouds, and so many other things that are present in the atmosphere. These can absorb the radiation and re-emit it, or they can reflect the radiation in so many directions, or they can let it through. So the radiation component that comes straight from the sun right through the atmosphere to the Earth's surface is called direct or beam radiation. This is the radiation that is of great importance. This is the radiation that we would want to capture for maximum collection, because it is the greater component of radiation that would give us energy. However, we cannot stop clouds from forming. We also want the rains. Therefore, as the radiation traverses through the atmosphere, some of it is reflected, deflected. So, at the end, this type of radiation will still hit our collector, but from all angles. And this component of radiation is called diffuse radiation. This component of radiation is measured from empirical data and evidence. It's found to be in the tune of 8 to 10% of the total radiation. In other words, if we were to look at the back of our solar panels, we would see that there is a figure that is written 1000 watts per square meter. That is the standard insulation that is used to design solar panels. So 10% of that on a cloudy day would give us 100. So in other words, if you've got a 1000 watts solar panel size, it means on a cloudy day it could only give 100 watts. And this 100 watts is entirely coming from the component of diffuse radiation. A smaller component, which is not very big to talk about, however, is the reflected radiation, because the Earth's surface is not smooth, is not horizontal. Hence, you find there are other places are mountainous, other places are flat. So we'll end up having a reflected component of the radiation that can still hit our collector and transform into the energy that we want. Therefore, in conclusion, knowledge about the Sun-Earth relationship and the various forms of radiation components will help us to design a solar system that meets our specifications. Do we want it to be reliable throughout the year? Do we want it to be least cost and meeting some specific loads during the night or during the day? How do we want to use the solar system? In other words, knowledge of the behavior of radiation will help us to determine and to size our system correctly such that it performs exactly to our expectations. Thank you, and don't forget to subscribe and hit the like button, and meet you next time when we will be talking about how to determine the size of the PV generator or the PV panel, or rather the number of solar panels that you can put. Thank you.